Hello and welcome. This is our fourth and last part of SVM series. Let's recap what we did till now. In part 3, we worked on two steps. First was loading the dataset in data frame and then data wrangling. That means pre-processing the dataset. Now, we have three remaining steps with us. We will go through these three steps now and understand them. The code written are using Python, and to write these codes I have used Jupyter Notebook. Well, remaining steps are splitting the database into train and test sets. For those who don't understand the purpose of training and testing dataset, it is necessary to understand this concept. When we develop our model, we perform three steps. First, select the appropriate model and train that model. Second is we test the model with our test data, and finally we check the accuracy. To understand this, let us consider our current data set. We have data set consists of approximately 700 records. These records consist of feature sets which we use to predict our predictor attribute or dependent variable class. The class attribute is having value either benign or malignant. Now, the question is, when we train this model, how to test it? So, for this purpose, we need some data set to test our model and determine its accuracy. But question is, how to determine whether the result we obtain is accurate? For this purpose, we need some known record set which contain the predictor or dependent variables value too. Hence, what we will do is we will divide our data set into parts. First part will be our training set, and second part we will use as test data set. In what proportion we should divide the data set in train and test data set? Well, there are several approaches, but one most adoptable approach is divide test and train data set in an 80 to 20 ratio. In some cases, they divide in 60 to 40 ratio. Well, we will divide our test and train data set in ratio of 80% and 20% for training and testing data set. One more approach is using multifold approach, where the whole data set is divided into 5 equal parts of 20% each. One part is used as testing data set, and rest all 4 folds, that means 80%, are used for training purpose. After developing the model, we test it, and again we use another 20% fold as testing set and rest 80% part for training purpose and check the accuracy. This is how we repeat the process for 5 times. This is best approach particularly to avoid overfitting and biased dataset problem. Okay, so that was about how to divide our training and testing dataset. Now let us write our code using Python. Look at the code. In first line of code, we use train test split function. Passing parameters are feature set x and predictor is y. Test size is 0.2, that means 20%, and random state equal to 4, which specify the randomness. Hence, now the train size is 80% and test size is 20%. We can see the output, and it shows that the train set is having X-train feature set with 546 records and 9 attributes, whereas the Y-train is having 546 data set. In case of test set, feature set X test is having 137 records, that is 20% of the total data set, and Y test is having 137. Now our train and test sets are ready. It's our time to fit the model using SVM. The SVM algorithm offers two choice of kernel functions for performing its processing. Basically, mapping data into higher dimensional space is called kernelling. The mathematical function used for the transformation is known as kernel function and can be of different types such as linear kernelling, polynomial kernelling, radial bias function that is known as RBF kernelling or sigmoid kernelling. Each of these functions has its own characteristics, its pros and cons, and its equation. But as there is no easy way of knowing which function perform best with any given data set, we usually choose different function in turn and compare the result. For this particular work, I have selected RBF. I recommend that you apply other kernels and compare the result. If you look at the code, we use SVC function and pass kernel RBF, and then we fit the model using feature set X train and Y train. As a result, we get our model. Next task is to predict using test set. Now, we will test the model with our test set. We pass XTest feature set to the model and get the prediction in form of Y hat. We will compare our obtained Y hat results with the known set of our Y test results for accuracy. So, let us look at the code. We obtain Y hat, that is prediction for our feature set X test. We display obtain first 10 results of Y hat. You can see first 10 sample results of Y hat. Now it's time for us to check the accuracy. We will check the accuracy of our model using confusion matrix and plotting it. We will also use F1 score and Jaccard Similarity Score for evaluating accuracy of our model. To check the accuracy, first, we use confusion matrix. For this purpose, we will import classification report and classification matrix module. Classification matrix will be used to check the accuracy. A confusion matrix is a table that is often used to describe the performance of a classification model or classifier on a set of test data for which the true value are known. It allows the visualization of the performance of an algorithm. For this purpose, first of all, we will write function to plot confusion matrix. This function prints and plots the confusion matrix. It is self-understanding function which you will be understand easily. Since the function is little long, I have divided it in two parts for display purpose. Remaining function will be seen in following slide. This is remaining part of a function. I wish that you can pause current and previous slide and follow it properly. It is self-understandable function which we will use to display the confusion matrix. Now, we will write code and implement the function to display confusion matrix. We call confusion matrix function and pass y-test and y-hat vectors which we wish to compare for label equal to 2 and 4, which signify benign and malignant type. We give precision equal to 2 to display the output with 2 decimal precisions. Then we display the classification report for y-test and y-hat. You can see the output which shows precision, recall, F1 score and support value. We will understand it in following slide. We will plot the confusion matrix using function plot confusion matrix. The code is very simple to understand. Now let us understand how to interpret the result. If you see the result, it shows that out of total 137 test predictions, 85 out of 90 results are actually no. That means value of y-test was no and our model also predicted them as no. That means y-hat value was also no. 5 results which were actually no, that means y test value was no and are wrongly predicted by our model as yes. That means y hat value are predicted as yes. It means 5 data points which were supposed to be false are wrongly classified by our model. Similarly, no results are classified incorrectly by our model. It means y test was yes and y hat did not show them false. And finally, 47 data points which were actually positive are classified correctly by our model and as positive. In other words, it matched our y hat result with the y test result. Okay, so let us understand F1 score and interpretation. Now, let us understand F1 score. Look at the image and it will give you very clear idea to understand F1 score. F1 score is a harmonic mean of precision and recall. First understand what is true positive and true negative and false positive and false negative. True positive is actual, it is in actual it is true and predicted value is also true. True negative is actual value is false and predicted value is also false. False positive is actual value was false but the predicted value is true. Similarly, the false negative is actual value was false and predicted value is also false. Precision is ratio of true positive and sum of true positive and false positive. Whereas the recall is ratio of true positive and sum of true positive and false negative. We calculate precision and recall here and then calculate F1 score. However, we have inbuilt function to calculate F1 score, so in real we don't need to calculate precision and recall separately. So let's look at the code. We use F1 score function here and pass y test and y hat and use average with value weighted. We get output 0.96390. It is very close to 1 and we can interpret that our model is highly accurate with accuracy level of almost 96.39%. Now let us check other model which is called Jaccard Similarity Score. It is statistic used for similarity and diversity index. And we observe from the figure about Jaccard, the value is between 0 and 1 and more it is close to 1 shows the highest accuracy. We use Jaccard Similarity Score function to calculate Jaccard score to which we pass y test and y hat. Output is 0.9635036. It is very close to 1 and hence signifies that 96.39% of test feature sets are evaluated accurately. So that was our journey of SVM. We conclude our session here. We observe that our model is highly accurate and provide accuracy almost above 96%. To understand Jaccard score, and F1 score and how it actually works statistically, we need separate session. But I tried to give you some simple interpretation about them. I hope you like this session and it will help you to understand SVM and also implementation of SVM using Python. I wish you to apply it and at your own and check the results. Thank you very much for being with me throughout the journey. I will come with new lecture series soon on other topics. Share knowledge and grow. Wish you very happy coding and machine learning. Thank you. Have a great day.